I hope everyone hear me. So we'll start session.
We are ready, sir.
Yeah. 1 second. Yeah, Birendra Kumar Singh, we login for 3 times. Okay, fine, no problem, no issue. So we'll start session. Yes, previous class about that introduction topics finished. Yes, today topic is interpreter versus compiler. Interpreter versus compiler. This is the most important topic. If you know this topic, easy to understand. Easy to understand Java. Yes, let us see. Interpreter versus compiler. Interpreter versus compiler. Let us see about interpreter versus compiler. Okay. Yes. Let me take Word document. Yes. Interpreter versus compiler. 1 second. Let me mute all. Yes. Okay. Fine. Yes. Interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. Let us see this. Yes, interpreter and compiler. Interpreter and compiler. Interpreter and compiler both are converting from high level language to low level language. Both are doing same jobs. Both are converting from high level language to low level language. But the way it's working is different. The way it's working is different. Okay, the way it's working is different. Okay. Let us see one by one here. How interpreter working, how the compiler is working. Okay, so let us start with the interpreter. How interpreter is working here. So how the interpreter is working. Yes, suppose some program statements. Yes, interpreter. Interpreter working on some source codes. Interpreter source code. There is a source code. Source code means, so what are the program we are writing here? The programs we are writing, that is called as source codes. Our programs are source codes. Okay, for example, here, let us take some Python program. Python is interpreter based. Okay, test.py. So Python program, test.py. Okay, see Python, D drive, Python folder here. Okay, Python. Yes, here location, D drive, mn drop Python. Let us go to CMD, command line. Yes, command line D colon, that will take D drive. Yes, in this dir, see mn drop Python directory. Yes, let us go to cd. Yes, mn drop hyphen Python. Okay, Python directory. cls, clear screen, dir, output is like this. See here test.py. Python file, test.py. Notepad. Yes, test.py. Yes, open this is not this Python script. A equal 10, B equal 20, C equal to A plus B. Next print addition equal to subtraction equal to. Next one more here. C equal to A into B. C equal to A into B. Yes, multiplication equal to. Yes, multiplication. Yes, multiplication. Yes, multiplication equal to. Say displaying C. Save. Yep, this code is called a source code. So what are the program we are writing? That program is called a source code. Maybe Java program, maybe C program. So our program is called a source code. It's a source code. This is source code. It's a source code. Yes, how the source code is working? Let's see. Save and close. Save and close. Go to terminal here. Yes, here dir. See, test.py. 98 bytes. See, enter key. Yes, test.py. 141 bytes means there's some code added. Okay. Now, how to run this? Directly running Python. Okay, test.py. That code directly running. Yes, directly here. So what's up? It's the interpreter here. Interpreter. That interpreter taken that code here, code line by line checking here. Suppose first line is correct, converts into binary code, executes, and giving output like this. Giving output like this. Suppose here some issue. For example, here suppose some error. Control S, save it, exit. No letters on this. Directly submitting here. Yes, no errors checking directly submission. Directly I'm running here. See error message. See here C equal to A plus B, that equal to missing, right? Something is missing here. So stop. Line 5 error stopped. So whenever error comes, simply stopping here. So what is happening here? So first one checking this is correct. Executed A equal 10, B equal 20. Here stop the program simply. Here error, right? Here error stopped. Okay. Now let us see. Yes. See. Python. Yes. Interpreter. Test.py. Yes. First statement. Next statement like this. Yes. Next statement. Suppose this is your source code. Source code statements like this. Next statement. Yes. Next statement. Yes. This is your source code. Next statement like this. Next statement. Yes. Next statement. Some source code. Yes. Assume like it's a source code. Like a source code. It's a source code. Okay. Now, how this is working here? Now, interpreter. First interpreter. So this is your program file. Maybe test.py file. Maybe Python script file. Maybe HTML script file. Maybe shell script file. All these are scripting. Scripting is interpreter based. Now, what happens? How it's working here? So, interpreter checking first line. So, first of all, interpreter check the syntax of first line. Checking syntax of first line. Syntax means some rules. There are some rules here. Rules means something like open double quote, close double quote, open bracket, close bracket. There are some rules here. There are some rules. Okay. There are some rules. Okay. Now here, so interpreter checking first line. Okay. Suppose, yes, here checking first line. Suppose first line is correct. Yes, no syntax or nothing. Everything is correct. Fine. If it is syntax correct here, then if syntax correct, now this code converts into binary code. Zeros ones format like zeros ones format. After converting, yes, submit to processor. Okay, processor taking this code and execute generating output. Okay. See, interpreter checks the first statement. If first statement is correct, immediately converts into binary code. After converting to binary code, submit it to processor, then generating output. Right? So first statement completed. Okay. See, next statement may be right or wrong here. Interpreter never looking for next statement. Suppose if the statement is correct, immediately converts into binary code. Submit it to processor and generating output. Okay. After this, go to next statement. Checking for next statement. Suppose next statement also correct. Same process. Simply it converts into binary code. Just it converts into binary code. Zeros ones format like this. Converts into binary code here. Same thing. Submitted to processor. Submitted to processor. Then generating output. Okay. Next. So first statement checking completed and output also generated. Second statement completed here. Output also generated. Once correct, immediately converts into binary code, generating output. Next correct, immediately converts into binary code, getting out. So what's happening here? Line by line. First line checking, correct, convert into binary code and given output here. Second line correct, converts into binary code and generating output, right? Okay. So line by line checking and generating output. Next line, suppose checking for next statement. Suppose something wrong, stops. Any error comes, simply stops. Okay, only one error shows here. Any error is there, simply stops. Same thing. Just now I showed, right? See, notepad. See here. So this is first error. Suppose let us make it one more mistake. One more. Yes, see this. Now run it here. See, first error. See this. Subtraction equal to here. Invalid syntax, right? Yes. So only one error here. Only one error showing this is. Only one error. Okay. Yes. See here. Like this. A, B, like this. Some statement like this, right? So what is happening here? In scripting here? Yes, in this interpreter based, what is happening here? Checking first statement. If statement is correct, simply converts into binary codes, generating outputs. Next statement checking, converts into binary code, then generating output here. Suppose any error comes, simply stops. Simply stops. This is working of interpreter. So interpreter shows only one error. If any error comes, simply stops there. This is working of interpreter. Okay. Now let us go to compiler here. Compiler C program. Let us go for C programming. C programming. Yes. C is a compiler based. Yes, how it's working? CD. Suppose mn Yes, present working directory mn ls. 1 second. Sorry. ls. Remove star. 1 second. I think they are important files. CD dot ls cd x location. Present working directory x here. Yes, rm hyphen r star. Deleting all this. Yes, present working directory x. Okay, present working directory x. ls nothing here. Now, same program. Let us write in C language. zreach. Yes, program. Suppose test.c. zread test.c. Open this is. Now here writing program. C program. Hash include stdio.h. Hash include stdio.h. Next white main function starting ending. Yes, in this. So first int a equal to 10. Okay. Yes. Next int. Yes. Like a Python here also same program I'm writing here. Next int c declaration. Yes. After this. Next c equal to a plus b. Yes. Printf. Yes. Addition. Yes. Addition is equal to yes. Personal d. Yes. Comma c. So addition value semicolon slash n. Next line. Okay. C equal to a plus b. Next like this. C equal to a plus b. C equal to a minus b. Next printf subtraction is equal to percentile, not percentage. Percentile d. Yes, displaying c value. Next c equal to yes a into b multiplication. So multiplication equal to yes multiplication is equal to yes percentile c. That's it. So this is C program. Compile. Yes. Close. Save it. Yes. Save. Yes. S.c. This is notepad. It's in Linux notepad. Save. Control yes. Save. Save and close. Present working directory x ls. See the test.c program. So this program, right? Now this program we can't run directly. Python program we can run it directly here. Python program. Yes. CLS notepad. C equal to a plus b. Yes, comma here. Control yes. Save it. Exit. Now Python program directly running here. Yes, Python. Yes. Addition, subtraction, multiplication. Directly program running. That code submitted directly here. No errors, checking, nothing here. Directly working here. Directly submission here. The script directly submission here. No checking of errors. But when come to compiler based, is interpreter based. Interpreter. So initially not checking for errors. Yes, first checking for error. If it is okay, then execution immediately. Interpreter how it's working here. Checking first statement. If it is correct, immediately executes and generating output. Second statement correct. Immediately converts into binary code, giving output here. Any statement wrong, simply stops there. But see what happens here. C language, compiler, test.c. This test.c can't execute. Okay. So first of all, you have to compile it. cc-c test.c. Yes. Compile no error. Without any errors, compile ls. Some test.o file generated. It's a binary code for your C program. Binary code. Test.o contains binary code. Now this binary code we should convert into exe file. cc-o. Suppose exe name is, let us say, project. Project is a final project builder. Okay, test.o. Now test.o convert into exe file. Convert it ls. See that exe file. The green color means exe file. Now let us run this project exe file. project.exe file. Project.exe, right? Yes, executed, we got the output, right? So we got the output. So what's happened here? First it compiles. After compilation, no errors, if no errors, generating exe file. See what are the steps in this? So first step is cc-c means only compilation. First it compiles. What's a compilation process? Checking for errors from top to bottom. Checking for errors from top to bottom. Yes, compile, no errors. No errors. No errors. Generated one test.o file. Now this test.o file, next step is converting it to exe file. Converting it to exe file. That project exe, result exe this is. Okay. Test.o converted into exe. So project exe generated ls. Now see that project exe. That project exe dot slash project execution of exe file is like this. Exe file executed and given output directly. So at a time output, right? Top to bottom executed and given output. So this is difference between interpreter and compiler. Okay, let me explain very clearly. Now this is interpreter. Okay, now let us go to compiler. How compiler is working here? Compiler. Yes, compiler. How compiler working? Compiler. Suppose test.c, C program. Test.c. 1 second. Yes, ls remove. Yes, star.o object file removed here. Next remove project file p star removed here ls. So present working directory test.c. Present working directory x test.c. Now c edit test.c. Test.c, open that. Yes, let us make it some mistakes. Semicolon missing here. Suppose comma missing here. Next here maybe here semicolon missing. Okay, here some comma missing. Save it. Save and close. Now let us compile. What happens here? Now what's the result of this compilation here? cc-c. cc-c. So what's happened here? So first 9th line error message. Okay. Yes, next 11th line error message. Next 19th line error message means top to bottom check it, right? See, in case of interpreter based, what happened here? Only one error showed. Only one error. Wherever error comes, interpreter stops. Interpreter shows only one error. If any error comes, interpreter stops. Any error comes, interpreter stops. Okay, only one error. But compile is not like that here. Compiler checking from top to bottom, all the lines, complete code. Now it is showing all the errors. 9th line error, next 11th line error, next 19th line error here. All the errors. So compiler checks the complete code from top to bottom. Interpreter is line by line. Interpreter checking is line by line. Interpreter checking is line by line. But compiler is whole program from top to bottom. So compiler checks from complete program from top to bottom. Okay. See what's happened here. Yes. If it is compiler, no compiler. Yes, compiler. Let us see about compiler here. Compiler working on source code. Compiler working on source code. Compiler working on source code. Suppose test.c. Or compiler working on test.c file. How it's working here? So checking for the first line. Suppose first line is correct. Even correct, it won't convert into binary code immediately. No, it won't convert. It won't happen like this. Okay, just checking, but it won't convert. But what happens in case of interpreter here? Interpreter first line is correct, immediately convert into binary code. Then giving output. Second line correct, immediately converts into binary code, generating output. Suppose something wrong here, stops. But in case of compiler, what happens here? Checking first statement, correct. Then code next statement, correct. But it won't generate binary code immediately. It won't generate binary code. Okay. Next statement. Suppose something wrong. Error at third line. After that, checking for next statement also. Even error getting, it goes next statement also. Okay. Even it's error, it goes next statement also. Checking next statement. Suppose again error here, somewhere error. Error at some line. Okay. Checking for next statement. Yes. Maybe suppose here error here. Checking for that, showing error here. Next like this. So compiler checks the whole code from top to bottom. Compiler checks the complete program from top to bottom. It shows all the errors. Compiler shows all the errors. But interpreter is only one error, right? Any error comes, simply stops. That is interpreter. See, in case of interpreter here, first line, correct. output also getting, second line correct, output also getting, third line something wrong, stops. But compile is not like that here. Top to bottom, checking all the statements from top to bottom shows all the errors. You can see in case of compiler what's happened here, all the errors top to bottom, every error showed, right? All the errors showed, all the errors. Now correct all these errors here. Let us correct, okay. Correction of these errors, semicolon, save. Okay, after that, now let us compile once again here. Yes, no errors. 11th line, yes, 19th line, two errors, right? One error solved. So like this, one by one, correction of errors, correction of errors. So next error, here it's a comma missing, comma missing. Okay, next here it's a comma missing. Okay, right? Yes, after correction of these errors here, again submit, again compile. Yes, compile. Yes, one more error, still one more error. So what is that error? Printf. Yes, 19th line, expected semicolon. So before printf, semicolon, expected semicolon before printf, right? Before printf. So before printf, expected semicolon means this is missing here. Semicolon. Save. Yes, after saving here, now let us compile this. Compile. It's done. No errors. No errors. If no errors, generated .2 file, test.2 file. Now this tested.2 file we should convert into exe file. That yes, -o project is exe name, test.o, test.o file. Yes, exe generated. Okay, project exe generated, right? So if no errors, what happens here? Next converts in exe. Next step is what? First compilation, checking for all errors, checking for all errors, top to bottom, checking for all errors. Suppose if no errors, generating one exe file, generating one exe file. Now that exe file executes, right? Yes, that exe file executed. Yes, at a time generating output here. Project exe file executed. Okay. So in case of compiler based, what happens here? That exe file executed. Yes, in case of interpreter, what happens here? Directly source code executed. See, directly source code executing, right? Yes, Python is the interpreter based language. Directly source code executing. Directly source code executing. Okay. See here. Yes, if it is interpreter based, directly source code executes. But if it is compiler based, what happens here? It generates one exe file, then executing exe file. So this is main difference. What's the difference between yes interpreter and compiler? Main difference is exe file. If it is interpreter based here, yes, statement by statements, line by line, converts into binary code and generating output. Convert into binary code, generating output. Line by line, checking conversion, then execution. But in case of compiler, what happens? Checking from top to bottom, and shows all the errors. Compiler shows all the errors. Interpreter is only one error. Interpreter is only one error. Okay. Yes. Interpreter is only one error. Now here, so compiler. Yes, correction of all the errors. Correction after correction here. Recompilation, right? Recompilation. So next time compilation. Suppose recompilation. Suppose here no error. Okay. Yes. Suppose here also no error. Yes, here also no error. Everything is correct. Then what is next step here? If everything is fine, so what is next level? So next level is generating exe file. It opens another file. That project exe, right? The project exe file. This whole code converts into binary codes right to this exe file. So this is yes, first statement converts into binary codes. Next statement converts into binary codes. Next statement by statement, all the top to bottom, all the statements at a time convert into binary codes. All the statements. Okay, that they're building that project exe, right? Project exe created. After creating exe file, then executing. So exe file generated here. Okay, exe file generated means the project exe, right? Project exe file generated. Exe file generated. Exe file generated. It's exe file. Now this exe file directly submitted to processor. Exe file submitted to processor. Submitted to processor. Processor generating output. Directly getting output at a time. So this is difference between compiler and interpreter. So main difference between interpreter and compiler. Compiler generates exe file. Interpreter, it won't generate exe file. Compiler generating exe file. Interpreter does not generate exe file. This is the main difference. What is exactly exe file? Yes. If you know that exe file concept, then you can understand independent platform, Java independent platform. Yes, next topic we'll be discussing. Just a couple of minutes, I'll explain that. Now, let us see. Difference between interpreter and compiler. 1 second. Interpreter versus compiler. Yes, let us see point space. See, interpreter, next compiler, interpreter and compiler, interpreter and compiler. Yes, interpreter and compiler. How they are working? Let us see one by one here. So first one, interpreter. First one, yes, interpreter checks the code. Interpreter checks the code. Interpreter checks the code means your program code line by line. First line checking if it is correct, converts into binary codes and submit to processor getting output here. So line by line. So interpreter checks the code line by line, checking code line by line. Yes, what is compilation? Not line, whole program top to bottom. It checks whole program. Yes, compiler. Say interpreter checks the code. Interpreter checks the code line by line here. Yes, compiler. Yes, it checks the code. It checks the code. Yes, it checks whole code. Whole code from top to bottom. Checking from top to bottom. Top to bottom. Checking from top to bottom. Checking from top to bottom. Checking from top to bottom. Okay. So first difference. Interpreter is line by line checking. Compile is whole code from top to bottom. Okay, right? Next, here generates output. Generating output here. Generates output line by line. Generates output line by line. So first line correct, generating output here. Second line correct, generating output. Third line something wrong, stops. Now this at a time output here. At a time. So at a time here it's exe file executing, right? Exe executing at a time giving output here. So at a time output here. At a time output, not line by line, at a time. So top to bottom execution and giving output at a time. At a time output. Okay. Next, in case of interpreter, any error comes, stops. That means it shows only one error. Only one error. It shows only one error. Yes, compiler, all the errors from top to bottom, all the errors from top to bottom, all the errors from top to bottom, all the errors from top to bottom. From top to bottom. Okay, from top to bottom. So interpret is only one error, but compile is all the errors from top to bottom. Okay, right? Yes, next. Exe file. Yes, it does not generate exe. No exe file concept in interpreter based language. It does not generate. It does not generate exe file. It does not generate exe file. Exe file. Yes, compiler generates exe file. This is main difference. Okay, so what's the difference between interpreter and compiler? First point you have to present this one here. First point this one here. What's the difference between interpreter and compiler? Main difference is exe file. Compiler generates exe file, but interpreter never generates exe file. Never generates exe file. Okay, so interpreter does not generate exe file. Interpreter does not generate exe file. Yes, compiler generates exe file. What is exactly exe file? We'll discuss. Most important topic for us. About exe we should discuss. Most important topic, we'll discuss that here. Wait. Okay. Yes, next. See, if it is interpreter based language, what happens? Interpreter, whatever directly source code executes. See, Python. In Python here, directly the script executing, right? Directly script executed. Source code executed directly here. Okay, interpreter based. Yes, source code. The source code executes directly. Source code executes directly here. Source code executes directly. But what is compile? Exe file executes, not source code. Compiler based exe file executes. Exe file executes. Exe file executes. Okay, yes, in case of compiler, exe file executes. Okay, interpreter based source code executes. Here exe file executing. Okay, exe file executing. Okay, right? So here interpreter one, a source code executing directly here, but compile exe file executing, right? Yes. Interpreter based language. Yes, these are what? All scripting languages or interpreter based language. Yes, interpreter based languages are called as scripting languages. Interpreter based languages are called as scripting languages. These all are scripting languages. All these are scripting languages. Scripting languages. Okay. All these scripting languages. These are all are scripting languages. Okay. All scripting languages are interpreter based. So interpreter based language called as scripting language. Compiler based language called as programming language. It's a programming language. Okay. Scripting and programming is not same. Okay. Scripting, it's the interpreter based language. Interpreter based language here. Yes, programming, all the compiler based. All compiler-based languages are called programming languages. These are programming languages. These are programming languages. Programming languages. Okay, for this example, scripting language example, HTML is a scripting language. HTML code. Yes, let me show you HTML code. See HTML code. Yes, HTML. Yes, this HTML file test HTML. Open with Notepad. See this. Now this HTML code, right? HTML is a scripting. It's a scripting. So HTML, yes, is the interpreter-based language. Now, what's the interpreter? Browser. Browser is an interpreter. Browser is an interpreter here. It's a scripting language. It's a scripting language. It's a scripting language. Browser is an interpreter. For the for the HTML, browser is an interpreter. HTML is a browser understandable language here. HTML is a browser understandable language. Browser is an interpreter. Okay. So this source code executes directly here. See, it's an interpreter-based language. Source code executing directly. Open. See that? Yes, username, password, submit, something like this. Clear? Something like this. Okay. So this is a interpreter-based language. The source code executing directly. So HTML, example HTML, Python. Python is interpreter-based language. Next, Linux shell scripting. Linux shell scripting. It's interpreter-based language. 1 second. Linux shell scripting. Yes. CLS CD dot Russian work under LS. Yes. CD. Suppose mnref. Yes. See here there are some scripts. Suppose UQGen. ZDit. Yes. This .sh. This is shell script. Some shell script dishes. Okay. This script running directly here. Shell script. Yes. Bash. Using bash shell running directly. The source code directly executes given some result output. Output we got it. So what is a shell script? The script executed directly here. Script executed directly. Okay. It's in bash is an interpreter. See in Python is the interpreter. Like Python interpreter, Linux, bash is the interpreter. It's interpreter. That interpreter executing this script here. Okay. Yes. 1 second. See it. Suppose here something wrong here. Okay. 1 second. This is okay. Now something wrong. See. Stop it there only. Only one error, right? First error, line 7, command not found. Simply stop it there. 1 second. Yes, this is first error. Suppose let us make it one more error. Let us make it here one more error. Okay, some mistakes. Okay, now do that. See this. End of file expecting for this error. Stop it. It's not yes. Only one error. Stop it the error here. Okay. Yes. So directly the source code executing directly here. Source code executing directly here. Source code executing directly here. Yes. Here mistake. Here mistake. Okay. So here mistake. Actions. After this, scripting means like a language, like English language. Script means that is like a language. Script is like your language. Okay, like English language, like Hindi language, like a language. That program looks like a language here. Directly that language executes. Okay, but programming means that converts into binary format then execution. The script and programming difference is that here. Script means that will execute directly here. Yes, any program running directly, that's called a script. Okay, suppose that converting into exe format, exe file, that is programming. That's the difference. So scripting means that will run directly. See HTML code running directly here, right? HTML code running directly here. Okay, HTML code running directly, Python code running directly, shell scripting running directly. Those are called scripting here. Okay, yes. So HTML, Python, shell scripting. Next PHP is also scripting here. Perl is also scripting. Next JavaScript also scripting here. They are scripting language examples here. JavaScript. These are all scripting language. When come to programming language examples, for these examples, C, yes, C++, next .NET, C hash. Yes, these are programming language examples here. C, C++, .NET, C hash. They are compiler based. They are compiler based examples. These are interpreter based language examples here. What is Java? We'll discuss. Wait, our topic is Java. We'll discuss. Okay. See, if you know that interpreter and compiler, then easy to understand everything here. That's the reason I'm explaining about these all the prerequisites. Okay. Otherwise, I can go to Java features directly. So that is not correct. You must have this knowledge. Okay. Yes. Next here, next difference. So these are interpreter based language examples. They are compiler based examples. Okay. Yes. Next here, interpreter based. For example, here, interpreter based. Yes, notepad, not this code. Just I'm removing one statement, modified, code modified directly here, saved, control yes, saved here, saved, running. Right? That's it. So directly got the output, right? So anytime you can open, you can modify that code. Anytime you can open, you can modify the code. Okay. So open this 1 second here. 1 second can modify. Yes. Directly quote. Directly quote. Yes. Okay. Now place second quote. Okay. Saved. Now run this here. Submit this. Yes. Got the output here. At any time you can modify. Means it's open source. Yes. Scripting language is a open source that can be modified anytime. Anytime it can be modified. Okay. Yes. It's a open source scripting. Yes. Interpreter based language. Scripting language. Scripting is a open source. Open source. It's a open source. It's a open source. Yes, it can be modified anytime here. It can be modified at any time here. At any time. At any time. At any time, right? At any time. Okay. And come to compiler. Yes, can we modify? Yes, let us go to compiler here. 1 second. CD dot dot. Yes, CDX. X directly. Here, our program is there. Now here, I want to modify this code. I want to remove some statements. So what's it? Yes, project exe, right? Project exe. Gedit. No project exe. Let us open that exe file. Yes, opening just a minute. So opening. Exe. Yes, see this. It's exe. Zeros ones format, right? Binary code. See that exe format. It's a binary code. Can we modify this code? We cannot modify. Then what's the process here? Yes, it's not an open source. That exe file you can't modify. See, file project. What's the type of that file? Exe file. See this. File is a command line to check the type of the file here. Project. What's a project? Executable file. Means is exe file. Okay. Dynamically linked. Okay. Next here. Linux OS based exe file. Yes, this exe concept will be discussing now. Okay. Yes. Now that code cannot modify it. You cannot modify. So really, if you want to change the functionality, yes, you should take that source code. You have to take the source code. You have to modify the source code. After that, you have to recompile. Next, you should rebuild it here. So all the steps you have to require. So directly that code cannot be modified. You can't modify it here. So really, if you want to modify it here, zret test.c. Yes. Open that C program file here. Yes, modify. Suppose let us remove this statement here. Remove. Save. After that, next you have to recompile it. Okay. Recompilation. Yes. cc -c. -c. Yes, 1 second. Recompilation. Yes. -c. Yes. Recompile. Test.2 file generated. Generated here. cc. Yes. -o. No project exe. Project exe. Test.2 file. Yes. Sorry. Not L. O. Yes. Project exe generated. Regenerate the exe file. Okay. Yes. Project exe. Run it. Now got it. Right. This is a lot of process. You can't modify. It's not an open source. It's a closed one. Okay. So compiler based exe file. Right? Since it's exe file, it's not open source. Okay. Since yes, it is an exe. Since it's an exe file, yes, not an open source. Not an open source. It's not open source. Not an open source. Open source. Okay. open source, right? It's not an open source. Yet, yes. Next, one more difference. One more difference here. See, if it is interpreter-based language, no exe file concept. So, yes, interpreter-based language, interpreter does not generate exe file, right? Interpreter-based language don't have exe file, don't have exe file concept, no exe file concept. Interpreter-based language, no exe file concept, no exe file concept. Okay, interpreter does not generate. Wait, Java, I'll explain. Wait. Okay. Yes, interpreter-based language does not have exe file concepts. Yes, compilation, everything is exe file. Here, everything is exe based. Exe based here. It's exe based. So these are the differences between interpreter and compiler. Now, what is exactly interpreter compiler? This is clear. Okay. Now let us move to Java. Let's watch Java. Yes. What is Java? Is it compiler based or interpreter based? Let us see. Anyone, can you answer this? What is Java? Is it interpreter based or compiler based? Suppose these things, these no doubt, these are compiler based, no doubt. These are interpreter based, no doubt. What is Java? Is it interpreter based or compiler based? What is Java? So many are saying that compiler based. Output, your answers, compiler based. Yes. Let me explain. Here. After explanation, you the answer. Okay, Java. Let us go to Java. D drive, CD, some test folder. D drive, CD, /CLS, CD /D drive, DR. Suppose here some test folder is a CD test folder. Change of directory. CD means DR, CLS, DR. Now here this is Java program file. Yes, 1 second. Del star dot class. Deleting dot class file. DR, CLS, DR here. Yes. Test.java. Here they say test.java. Notepad. Linux is gedit. Gedit for Notepad. Here Windows is Notepad. Test.java. Yes, open that. See. Public class test. Public static void main. Yes. Hello test. Save. Exit. Now, what is first step? Compilation. We have to compile it. Yes, Java C tester Java compilation. Yes, compiles. Here, see this. After compilation, some tested dot class file generated. Del star dot class. Okay, deleted that file here. CLS DR. Now let us compile once again here. Test.java. Yes. Some mistake. Yes. CLS. Java C. Error message. Errors. Compile showing errors. There are 2 errors. Compile showing that 2 errors. It's a compiler. Compile checking out for all errors. Yes. In Java, first compiler checking for errors. Okay. Now correct this error here. Suppose correction of this error. Save. Exit. Now let us compile Java C. Yes. No error. If no error, generate one dot class file, right? Generate dot class file. So in Java, errors checking by the compiler. Okay. So first part, Java. So Java, what happens here? So first, yes, your source code, your Java program source code. Yes, source code. That source code, right? Source code. Nothing but the test.java. Test.java is a source code, right? Source code. That source code is given to Java C compiler. Java C compiler. Result is bytecode, not binary code. It's a bytecode. Yes, bytecode. So bytecode file generated. It's nothing but a tested dot class file generated. Okay, tested dot class file generated. So what is dot class file? Dot class file is bytecode, not a binary code. It's not exe file. It's a bytecode. Now we got tested dot class file. Okay, so tested dot class file got it, right? After getting tested dot class file, Now this one has to execute. Okay, test dot class. Now what is Java test here? Previously Java C with Java compiler. What is Java? It's interpreter. Java interpreter. Now this tested dot class for executing by the interpreter. Yes, executing by the interpreter. Yes, hello test. Hello test. So what's happened here? This bytecode given to Java means it's interpreter. Java interpreter. Interpreter given to interpreter. Okay. Yes, Java tested dot class file. Yes, given to Java. What is Java? It's interpreter. The Java is interpreter. So given to interpreter. So interpreter, right? Given to interpreter. Now what happens here? Interpreter. Yes, executing line by line. Interpreter executing first statement and giving output. Second statement, next output. Next statement, output here. So directly here. Yes, interpreter. Java interpreter converts into binary codes. Now the statement by statement converts into binary codes. After converting into binary code, submitted to processor, finally generating output, right? So what is happening here? There are two stages. Source code is converting into byte code. That is first stage. Next stage, byte code converting into binary code. But no exe file generating. Directly dot class file executing and giving output. Directly dot class file executing and giving output, right? So what is happening here? So first, source code to 1 second. Source code to binary code. Source code to byte code, first step. Next step is byte code to binary code. Byte code to binary code. Binary code. Then submitted to processor generating output. So it's happening two stages. So first stage, source code to byte code to binary code. There are two stages. Suppose C language or C++, source code directly converts into binary code. Source code converts into binary code and executing, giving output here. Even Python also, source code directly converts into binary code, giving output. Only one step, except Java. In all the cases, only one step, except Java. In all the cases, only one stage. But when come to Java, there are two stages. So first one, source code to byte code. So source code to byte code. This is by the compiler. Next, byte code to binary code. Next, second stage, byte code to binary code. By the interpreter, Java interpreter. Source code to byte code is a Java compiler. Yes. Next, byte code to binary code is a Java interpreter. So what's happening is two stages is working here. Java interpreter. Okay. See what is happening here. Errors checking by the compiler. In Java, errors checking by the compiler. First stage, errors checking. After checking errors, if no errors, generating dot class file. So first stage, errors checking. If no errors, generating dot class file. So first stage is completed. What is next stage? Interpreter taking that bytecode dot class. What is exactly bytecode? We'll discuss next. I'll explain bytecode very clearly. I'll explain bytecodes. Okay. Now here interpreter taking bytecode, converting it to binary codes, then generating output, right? So what is happening? Errors checking by the compiler. Yes, in Java. Yes, errors checking by the compiler. Errors checking by the compiler. But runtime. Who will run that code here? Interpreter. Runtime. Yes, runtime by the interpreter. Interpreter, right? So these two things are involving, right? Errors checking by the compiler, but runtime by the interpreter. So in Java, involving compiler as well as interpreter also. Now what is Java? Is it compiler based or interpreter based? Tell me. Now tell me, answer this question here. What is Java? Is it interpreter based or compiler based? No answer? Yes, guys, what happened? Explain very clearly. What is Java? See, errors checking by the compiler, but runtime by the interpreter. Now tell me. Both. It's a combination of both. Java depending on both here. Java depending on both. Yes. Both interpreter as well as compiler. depending on both. Now this point is clear, right? Yes, practically we'll see once again. Okay, so Java depending on both interpreter as well as compiler. Okay, Java depending on both interpreter and compiler. So what is Java? Is it interpreter based or compiler based? It's a depending on both. Depending on both. Java depending on both interpreter and compiler. Okay, fine. Next, see here. Try to understand this point here. Yes, you have to answer some question. I'll be asking some question. Yes, guys, please attention, please. I'll be asking one question. Try to understand it here. Yes, runtime. If runtime is interpreter based, any exe file concepts. Interpreter based language don't have exe file concepts. If runtime is interpreter based, no exe file concepts. If runtime is interpreter based, no exe file concepts. That point is very clear. Okay, runtime is interpreter based, no exe file concepts. That point is very clear. Okay, now Java runtime is interpreter based, right? Java runtime is interpreter based. Not tell me. Is there any exe file concept in Java? Java runtime is interpreter based. So is there any exe file concept in Java? See here, any language runtime is interpreter based, no exe file. Runtime is interpreter based, no exe file. Runtime is interpreter based means no exe file. Java runtime is interpreter based. So now question is there an exe file concept in Java? Java runtime is interpreter based. Is there an exe file concept in Java? Next, one more question. Can we create exe file in Java? Can we create exe file in Java? Can we create exe file in Java? No. No. Okay. Yes, in Java. Yes, no exe file concept in Java. See, Java dot class file is not exe file. Dot class is not exe file. Exe is different, dot class is different. I'll explain very clearly. What is exe? What is dot class file? I'll explain very clearly. Wait. Yes, no exe file concept in Java. No exe file concept in Java here. Yes. Reason? No exe file concept in Java. Yes, it is a yes. Yes, it is a yes. Interpreter based. It is yes. It is runtime. Runtime. Yes, runtime is an interpreter based. Is an interpreter based. So because of that reason, don't have exe file concept in Java here. Can we create exe file in Java? No. No chance. Okay. There is no exe file concept in Java. No exe file concept in Java. You can't create exe file. So this point is clear. Now, so first step in Java clear. Java is a interpreter based as well as compiler based. Okay, fine. Java is depending on both here. Okay, fine. Now, let us come to this point here. Yes, first two features. In Java features, Java is an independent platform, right? Now let us come to this one. Independent of platform. Independent platform. Independent platform. Yes. How Java made us independent? Now this is a question here. Independent platform. Okay. Yes. Independent platform. Yes. Now let us see about this point here. Independent platform feature. Yes. What is platform? Platform means what? Now you can answer this question. What is platform? Yesterday we discussed that. What is platform? OS. OS is a platform where we can run all the application software, right? OS. Platform means OS. Platform means OS. Yesterday we have discussed already. Here platform means say OS. Okay, don't say something answer here. Here platform means OS. Okay, on top of OS everything is running here. OS is a platform where we can run all the application softwares. Java is independent of platform, is independent of operating system. How Java made us independent of platform? That point we should discuss now. Okay. Yes. See, independent of platform means independent of OS. This answer, any trainer, any student, anyone, they will explain that. If platform means independent of platform means independent of OS means Java program running on any OS. That answer anyone says how? What's the reason behind of that? Yes, how made us independent of platform? This is important here. How it's made us independent of platform? Yes, how to answer that question here? To answer that question here, yes, first of all, you must have exe file knowledge. Exe file. Okay. Now question is here, what is exe file? Yes, what is exe file? Yes, anyone, can you answer this? These are all that real time. Yes, if you know that, if you have the working knowledge, if you, yes, you can. What is exe file? What is dot class file? What does it can? You should have this all this knowledge. Okay. Otherwise, how can you put up experience? Okay. Yes. Suppose if you know the basics, still you will be like a fresher, learning like a fresher. Maybe 2 years learning, 3 years learning, 4 years learning, still will be like a fresher. You can't answer real-time questions. Okay. See, what is exe file? Exactly what is exe file? What is exactly exe file? See, let us go to exe file. Exe file. See, generally here, what is exe file means? Anyone says that it's a binary code file. Yes. See, dot slash projects. It's exe file. It's a binary code file. Anyone says that exe file means it's in binary format. It's a binary format for simple answer. But exactly what is exe? I'll tell you now. What is exactly exe file? Okay. So generally here, what is exe means? It's a binary format code. It's a system understandable format. Anyone says this answer only. But exactly what is exe file? Let us see. Now remove t star, remove start dot. Yes. Object file removed. Now cc hyphen c test dot c. Compiling. Yes. Test dot to file generated. Now exe file. How that exe file is built? Now I'm building that exe file. Yes, that exe file I'm building here. How this is? See, project is the exe name. Okay. Test.ro. Test.ro. Now what happens? Yes. That exe build generated. That build is called a build. Final one is called a build. Maybe in Java or anywhere, final project is a build. It's a build generated. That exe generated. Now this exe project exe contains what here? That exe contains what? See, at the time of creation of exe file, what happens here? CC means C language compiler hyphen moments object file. Now C language compiler, that compiler taking test.o. What is test.o? It contains your C program code, binary code for your C program. Binary code of C program. Binary code of C program. Okay, binary code of C program. Next, one more here, binary code of C program. 1 second. Zrich test.c. See here, this is a header file, right? Hash include stdio data header file. It's a C language library. Yes, header file from the C library. This header file also, there is a binary code. There is a binary code for this header file. For this header file, there is a binary code. Yes, it's a predefined library. There is a binary code. Okay. Yes. Now here, test.o. This contains binary code of your C program. That 5 to 6 lines, main function, starting, ending. Okay. Yes. See. This code, only this code. Talk about this code. This code converts into binary format and write to .to file. The .to file contains only this code. This code, binary code of your code, binary code of C program. The tested .to file contains binary code for your C program. Next, there is a header file, right? Header file is also having some binary codes. Okay. Now, cc-o project test.o. What happens here? C language compiler hyphen moments all the object files, linking all the object files and generating project exe file. Linking object files. What are the object files? Test.o means your program binary codes, binaries of your C program. Next, binaries of your C software library means stdio.h. Binaries of standard IO.h. Okay. So binary code of your program, binary code of stdio.h header file. Next, binaries of OS library. Okay. So OS contains input output library. OS contains input output. That library also links to with project exe generating exe file here. Okay. What happens here at the time of generating exe file here? That yes, C compiler is taking your binary code of your C program, binary code of C program header file here, binary code of your program, binary code of that stdio.h header file, binary code of OS library. After linking all the binaries, generating finally exe file. Now this is exe file. So exe file contains what? So what is exe file? What is exe file? See exe file. What is exe file? See exe file contains okay. Yes, C program binary. Yes, C program binary code, plus next C library binary code, C library, binary code, C library binary code, C library binary code, plus OS library binary code, OS library binary code. So binaries of C program, binaries of C program, binaries of C library, binaries of OS library, binaries of OS library. That is finally exe file. Okay, so what is exe file? Exe file contains binary code of program plus binary code of library, software library, binary code of OS library. This is a case of C program, C exe file. Suppose if it is C++ exe file, what does it contain? C++ exe file. Same here. C++ program code, your C++ program code, C++ library, next OS library. Suppose if you .NET exe file, .NET program code plus .NET library plus OS library. That's it. Okay. So exe file linked with OS library. Exe file linked with OS library. So what is exactly exe file? What is exe file means? How to answer this question here? What is exe file? Exe file contains binary code. It's a system understandable language. Exe file contains completely system understandable language. It's a binary code. Binary code of what? Binary code of C program, binary code of library, binary code of OS. Okay, means OS library. So that exe file contains OS library. For example, get test.exe file. Yes, prepared on Windows OS. On Windows OS. Windows OS, right? Prepared on Windows OS. Then test.exe file links with Windows library. Test.exe file linked with Windows library. Okay. Test.exe file linked with Windows library. It contains Windows library. Okay. So you get test.exe file prepared on Windows OS. Yes, it links with Windows library, Win library. Links with Windows library. Okay, right? Okay, fine. Now question for you guys. Some question. See, test.exe file prepared on Windows OS. It links with Windows library. Now same this exe file can I run on Linux OS? Linux OS. This is entry question. Can I run a Linux OS here? Test.exe file prepared on Windows OS. Can I run a Linux OS? No, we can't run. Reason exe file is OS dependent. What's the reason? I'll tell you that also. That point also. Can we? Yes. Can I run a Linux OS? No. Answer is no. We can't run. Yes. Reason exe file is a OS dependent. Exe file is a an OS dependent. Is an OS dependent. Why? Exe file is an OS dependent. Okay, fine. Everyone says that exe file is OS dependent. That's okay, fine. Why? What's the reason? Reason it contains OS library. Okay, it contains OS. Reason here. Yes. Why exe file is OS dependent? Why? Question is here. Why exe file? Yes, exe file is OS dependent. Why exe file is OS dependent? So what's the reason here? Reason, simple answer here. Answer. Yes, answer. It contains OS library. It contains OS library. Okay, it contains OS library. Suppose exe file prepared on Windows OS, try to run a Linux OS, it fails. Same thing, try to run Unix OS, it fails. 1 second, I'll show that. For better understanding, I'll explain some one architecture on this. For better understanding, suppose hardware. On top of hardware, there's a OS. Hardware. On top of hardware, there's a OS. Let us take some OS. OS is, let us say, Windows OS. Okay. Yes, with Win library. Okay. Yes. Yes. Now, yes, file is test.exe file. Test.exe file. Now this test.exe file, yes, sir, but test.exe file prepared on Windows space. Test.exe file prepared on Windows space. Test.exe file prepared in Windows space. Now test.exe file moving on to same Windows space. Test.exe file, the test.exe file, just I'm moving on to Windows space. Okay, here placed on Windows space. Test.exe. Test.exe, right? Now what happens here? Now test.exe file, it will try to invoke Windows library because all are linked with Windows library. The test.exe file, it will try to call Windows library. It will try to call Windows library. Yes, Windows try to call Windows library. Yes, it's available. Just Windows library invoking here. So using that Windows library, it will communicate with hardware components. That's it. The test.exe file already linked with OS library. Using that library, it will communicate with hardware components. See, previous class explained about, yes, every program has to communicate with hardware through the OS library. Yesterday, that point mentioned very clearly. Yes, every program has to link with OS library to communicate with hardware components. Every program, first of all, should be linked with OS. Okay, every program has to link with OS library to communicate with hardware components. Now, what's happened here in case of C program exe file? At the time of generating exe file itself, that OS library linked, all are linked, means static link. At the time of exe generation itself, all are linked. So test.exe file is already prepared file on Windows space, already linked with Windows library. This type of link is a static link. Now placing on Windows space, yes, now it will try to invoke Windows library. Yes, it's available. Directly invoking Windows library, using that library, communicating with the hardware components. Communicates with the hardware components. Fine. Well and good. Now, same thing. Let us move to another platform. Let us take another platform. See, here, this Linux platform. Okay. That stands for Linux lib. Linux library. Okay. Now what happens here? Same test.exe file. One second. Same test.exe file. Moving on to Linux platform. Yes, test.exe file. Now try to run it. On Linux platform, try to run the test.exe file. What happens here? When you try to run test.exe file, it makes a call to Windows library. Okay. Now it will try to call Windows library. But what's the library? Linux library. So this library is not matching. Okay. Now test.exe file is trying to invoke Windows library, but here it's not available. That environment changed. Platform changed, right? So this library is not matching, simply fails. It will try to invoke Windows library on the Linux environment. It's not available, simply fails. So exe file is OS dependent. Okay. Now let us take one more platform. Unix platform. Same thing. Unix platform. Yes, go to Unix platform here. Yes, Unix. Now Unix OS. So Unix platform. So Unix that kind of Unix library. Okay. Now same test.exe file. Placing on Unix base. Now this try to run it here. Now it will try to invoke Windows library. Trying to call Windows lab, but is Unix type. That library is not matching, simply fails. That's it. Okay. So exe file is a OS dependent. Reason it contains OS lab. This is exactly answer. But no one will explain like this. I'm sure it's my challenge. No one will explain like this. What is exactly exe file? What does it contain? They don't know about this because basically I'm a embedded C background guy. Yes, from the beginning embedded C, later changed to Java. Okay. Yes. One second. Yes. Our topic not yet complete. We are still at exe file stage. Okay. Next 10 minutes, your answer and everything clear here. Yes. Now, so exe file is a OS dependent. Exe file is a OS dependent. Reason it contains OS library. Okay. So this is about exe file. Okay. So you get exe file at the time of generating exe file, it said yes, OS library linked with exe file. So exe file is a already prepared file. Exe file is a prepared file for specific operating system. It's a statically linking, already linked with OS library. Exe file is a already prepared file for the specific OS. So it's a OS dependent. Okay. Now let us come to Java. So in Java, this is a dot class, tested dot class. So what is dot class file? What does it contain here? Dot class file contains what? Now question is dot class file contains what? Yes. Yes. What does it contain here? Dot class file contains what here? Exe file contains C program code, C library, OS library. What is Java? Java dot class file. See, Java dot class file contains Java code in byte format. Java code plus Java library. That's it. No OS library. Java dot class file does not have any OS library here. Okay, in Java here, dot class file, dot class file does not dot class file does not contain any OS library. Does not contain any OS library. No OS library here. No OS library here. So dot class file is not a prepared file. Okay. So what is dot class means? It's a bytecode file. Dot class contains bytecode file. Java program in the form of byte format. Dot class extension is dot class. Tested dot class extension dot class here. The dot class contains bytecode. Bytecode. Java program in the form of bytecode. What is bytecode? We'll discuss. Wait. Dot class. What is dot class file? What is dot class file? Dot class file. It's a bytecode file which contains Java code and Java library only. Java program code, Java library. See, Java library also developed in Java. That means purely Java program. Okay. Dot class file does not contain any OS library. Yes, it is a purely Java program. It's a purely Java program. Purely Java program in byte format, not binary format, byte format. That means dot class file is not a prepared file. Exe file is a prepared file for the specific OS, but dot class is not a prepared file. Then how this is running here? See, here every program has to link with OS library, then communicate with hardware, right? Every program has to link. Suppose exe file, at the time of creating exe file itself linking, but in case of Java, it won't happen here. At the time of creation of dot class file, it won't link with OS library. It means it's not a prepared file. Okay. Now let us see same thing here. Let us compare Java here. What's happened Java here? Tested dot class file. So tested dot class file. Okay. Now tested dot class file. This tested dot class file purely Java code. Tested dot class file is not linked with any OS library. Now how this is running here? No tested dot class file. Yes, 1 second. Now here one more layer comes extra here. 1 second. One more layer. Now one more layer. Tested dot class file. Now tested dot class file placing on Windows. Okay. Windows. So tested dot class file placing on Windows OS. Okay, now how it's working here? See, tested dot class file move to Windows OS. Okay. Now tested dot class file don't have any library. Tested dot class file don't have any library. Yes, this tested dot class file has to communicate with hardware, right? How? Yes, it has to link with OS library. The tested dot class file, this tested dot class file has to link with OS library here. Who will link it? Somebody has to link here. Suppose if it is exe file, at the time of creation of exe file itself linking means already prepared file, static link. When come to Java here, Java dot class file don't have any OS library, but at runtime, even at runtime, it has to link with OS library. Every program, yes, will communicate with hardware through the OS library. Every program communicating the hardware through the OS library. Compulsory OS library has to involve in that. Otherwise, never here. But dot class file don't have OS library. then how it can communicate with hardware? Yes, the dot class file has to communicate with hardware. How it? Yes, no, it cannot communicate directly here. It cannot communicate. So compressor that has to link to AS library. We will link it here. For this purpose, one more layer, there is a JVM layer. Now JVM layer introducing here. Now what happens here? Now JVM takes the dot class file, just JVM taking dot class file here, linking with yes library here. So JVM taking dot class file here and links with Windows library. Links with Windows library. So JVM takes dot class file, links with Windows library. Once link established, then communication starts. Now JVM takes care of linking dot class file to OS library. After linking, then communicates with hardware. It's a dynamically linking here. Before going to run it here, the JVM links your dot class file to Windows library. After linking here, then executes and generating outputs. What is JVM? We'll discuss next. Wait. JVM means Java Virtual Machine. JVM means Java Virtual Machine. Java Virtual Machine is responsible to link your dot class file with Windows library, then executing and generating outputs. So it's a dynamically linking here at runtime. Before going to run it, linking and running. Linking, running with dynamically linking here. Dynamically linking this is. Okay. Now, same dot class file. Yes. One second. Now, same dot class file. Yes, next other platform. Let us take next platform, Linux platform. Linux platform. See Linux platform. Yes, Linux platform, Linux library. Now what happens here? Now this test.class file, placing a Linux, moves to Linux space. After moving into Linux space here, now Linux JVM taking test.class file links with Linux library. Okay. Now Linux JVM takes care of linking your test.class to Linux library. So what is happening here? Dynamically linking here. See test.class prepared. So here Windows JVM links to Windows library. Linux JVM links to Linux library. Similarly, Unix JVM links to Unix library. That's Unix JVM. If it is Unix base, Unix JVM come to picture. Unix JVM. It's a Unix base. Unix library. So Unix JVM is responsible to link your dot class file to Unix library. So once linking is done here, then executing generating outputs. Okay. Java Virtual Machine. Yes, Windows JVM, Linux JVM, yes, Unix JVM. Now here, doubt is here. JVM, is it part of OS? Maybe that is doubt, right? Yes, 100% getting out. No, it's not a part of OS. JVM is not a part of OS. Then from where getting the JVM here? From JDK. So once JDK install on Windows space, generating JVM. JDK on Linux space, generating JVM. Yes, JDK on Linux space, getting JVM. JVM is a part of JDK. So once Java software installed, JDK means Java software. Once Java software installed, then JVM get installed automatically. JDK means Java Development Kit. The Java Development Kit contains various kind of tools like Java compiler, JVM, Java library, GRE. Yes, we'll discuss. Here there is a point like what's the difference between JVM, JDK and GRE and Java compiler? These points we'll discuss next. Wait. JDK, JVM, GRE. These three things we'll discuss. Wait. Okay. Yes. Once JDK installed, getting JVM also. Next, one more thing here. Java program is independent of OS. Java program is independent of platform, but JVM is OS dependent. Okay. Java program is a dot class file. But what is JVM? JVM is exe file. Yes, JVM is a exe file prepared in C++. C++ exe, that is. JVM developed in C++. I'll explain. Yes, when you're running program here, how C++ code is working in the background. I'll explain. Going forward, we'll discuss that point also. I'll explain. I know that how JVM was developed. Yes, behind of JVM some C++ code. I know that code also. I will explain that code also. Okay. Yes, because I have the embedded C knowledge, very experienced in embedded C. That's the reason I know that how JVM was developed. Even that also I'll show that. Now JVM is exe file. Dot class dot this is not Java program is not exe file. Dot class file it's a waste independent. Dot class file is waste independent. But JVM is exe. Since it's exe is waste dependent. See, anywhere exe means is a OS dependent. JVM is a exe file means OS dependent. For Windows space, one JVM. For Linux space, another JVM. For Unix space, another JVM. See, Sunsoft, they have developed different JVMs for different operations. Sunsoft, they have developed different JVMs for different operations. See, Windows JVM is having knowledge of Windows space. Linux JVM is having knowledge of Linux space. Yes, Unix JVM is having knowledge of Unix space here. So JVM is OS dependent. Okay. See, 1 second. Suppose installing JDK. Suppose download some JDK. Installing can I install on every base? No. JDK downloaded. Can I install on every operation? No, I can't. Because JDK contains JVM, the JVM is OS dependent. Suppose if you want to install Windows here, you have to download Windows JDK. JDK for Windows OS you have to download. Suppose if it is Linux, JDK for Linux, separate JDK you have to download. For Unix OS, separate JDK. So JDK OS dependent. So JDK changing from one OS to another OS here. JDK changing from OS to OS because the JVM is a OS dependent. Okay. So separate JDK you have to download, you have to install on different operations. So once JDK installed here, then getting JVM, that JVM is responsible. JVM is responsible to link dot class file with your OS library. JVM is responsible to link dot class file with OS library. It's a dynamically linking. In Java, this link is a dynamically happens here. At runtime linking and giving output here. In C language, at the time of creation of exe file itself, linking. C language exe file. If it is exe file, it's a static linking. Exe file with exe file, OS library linking at the time of generating exe file, not runtime here, not runtime. That is static linking. Exe file is a static linking, but dot class file is a dynamically linking here at runtime. So before going to running here, first linking with OS and running. Next linking with OS and running. Linking with OS and running. It's a dynamic linking here. So this is concept behind of independent platform. So JVM is responsible. JVM is responsible to make the Java program as independent platform. Is it clear? At this point, independent platform. This point is it clear? What is JVM? I'll explain later. Don't worry. What is JVM? What is JDK? What is JRE? Later I'll explain. Yes, I hope everyone you understand that independent platform, right? Independent platform. Is it clear? 1 second. I'll tell you one point here. See, independent platform. Yes, independent platform. Yes. See, to explain about this point. To explain this point here. Yes, many prerequisites we discussed. So directly if I'm explaining independent platform, no one can understand. Of course, trainers will explain. What they will explain? Independent platform. Java program is independent platform. It's independent of operating system. Reason JVM takes care of everything. Okay. They says that here they will simply explain that JVM is responsible to make the Java program as independent platform. Over. Only matter of 5 minutes explanation. They'll go to next. But how many days explain? Almost 2 classes. Yesterday class and today class. Only one feature. Yesterday, today topic. See, without interpreter and compile knowledge, you can't understand this one, right? Yes, to understand independent platform, these features here, to understand this one here, explain about OS, next explain about exe file, next explain about interpreter, explain about compiler, explain about different environments, right? Without explaining that fundamentals, you can't understand. That's the reason started with fundamentals. Okay. Yes, maybe somebody yesterday, today, beginning, maybe thinking, somebody maybe thinking, yeah, this trainer is explaining fundamentals. Yes, he's not explaining actual Java. Maybe somebody thinking like that. No. The thing is here, if you know that fundamentals, you can understand this independent platform. Okay. Next. Yes, next is portability. Even for portability also, whatever we discussed yesterday, today topic is useful for the portability. For portability also, yes, yesterday's today topic is useful. Okay, portability. In portability also, there are a lot of explanation is there. One second, one guy asked some doubt here. It comes under portability. What is doubt is here. One second, just wait. Yeah. One second, wait. This doubt is, then which file is generated on Linux base? Exe file only run on Windows OS. Yes, Gaurav, these are your doubts. For this answer tomorrow. For this question, in portability concept, I'll explain. Java is a portable. Yes, tomorrow also almost 45 minutes only for portability explanation. Next, rest of the features like oops language, that is matter of 10 minutes, scalability 10 minutes. So tomorrow we'll finish all the features. Tomorrow finishing features, next class, installing Java, installing JDK, next installing Eclipse, starting Java programming. So tomorrow finishing all that features. Right? Yes, any doubts? Yes, tomorrow very interesting topic. Yes, that portability concept is very, very interesting here. Yes, we'll see that real time will be there. In portability, I'll explain some real time environment. What is happening in the production environment? The topic will be discussing in portability concepts. Okay. Yeah. So that's all for today. Any doubts? Yes, guys, any doubts? Yes, are you understanding my topics clearly? Hello, guys. Yes, are you understanding? Okay, fine. Fine, thank you. Yes, tomorrow we'll continue for the features. Tomorrow features finishing. After finishing features, next we'll go to programming here. Okay. Yes, in programming also, how that program is work. Behind the program, what is happening with memory map, I will explain. With memory map, I will explain here. What is happening in memory here, like heap memory, stack memory, static memory. In program, what is happening at runtime? Yes, I'll explain very clearly. Yeah, I'll share that material. Today I'll share it. So by 11 o'clock, we'll be receiving that material. Okay. Yes, I will take your mail IDs. Yes, see, I will take your mail IDs from the online team. Online team, they, I think, already forwarded, I think. So as per online team information, yes, I'll share these documents. Okay. See, I request you guys, anyone pending in registration, please register. So your material and everything will be shared immediately. Okay. Yes. Any guys, any doubts? See, 100% it's a real-time oriented, no doubts. Very clear explanation, like a spoon feeding each and every topic, slowly and repeatedly explaining here, every topic. That is my guarantee, no doubts. Okay? Yes. Right. So thank you guys. See you tomorrow. See you tomorrow. Thank you. Yes, have a great night.